I am the founder of whatifi. What we're trying to solve is complexity, scenario planning, and the ability for business decision makers and their teams to rapidly build what-if scenarios in the multiverse. So what's an example? Maybe I run a project-based industry. It could be a construction company. It could be a gaming company. It could be a film and television post-production studio. What if we land all the projects in our pipeline? What if we just plan for the ones that have an 80% chance or more? What if that big, huge project that we were planning for is going to keep the whole company afloat for 6 months, gets delayed by 3 or 4 months? These are the kind of scenarios that business owners are grappling with all the time. And as you can imagine, it is not easy. The traditional weapon of choice is a spreadsheet. And again, I love spreadsheets. I think they're fantastic. But there's definitely some limitations. The challenge with the spreadsheet is, first and foremost, it's not really a timeline, right? What it is a proxy for time. Time doesn't truly exist. I know there's going to be some people that are going to disagree with me on that one. But if you come from the world of film and television, you come from a world where time is the first axis. It is the thing that sits underneath everything, is a timeline. Imagine you're on your family vacation. You have these clips from your time in Mexico. You put one clip on the timeline, another clip on the timeline. You slide those around, when they start, when they end. Then you click the big render button, and it goes through frame by frame by frame and generates your images. In business decision making, it's very easy to say that 1 + 1 = 2. But 1 6 months from now and another 1 8 months from now no longer equals 2. When matters, not just what you actually do. And that's one of the primary challenges with a spreadsheet, is they're not inherently wired. Can you hack it? Can you be a guru? Can you figure out a way to be able to do that as a ninja? You can, to a degree, but I'd argue it's still very binary. What do I mean by binary? Binary means that a value can really only exist in one state at a time. Your big, huge project has a 90% chance of landing. You think it's going to be worth $5 million. That's binary. Someone has made that decision. That's absolute until you choose to change it. And if you want to change it, it's really, really messy. You're either going back to your source, whether that's HubSpot or Salesforce or your fancy Google Sheet, and you're changing some numbers, you're copying and pasting, you're breaking that history and that hierarchy. Now instead, let's think about decision trees, right? If you start thinking about decision trees, I'm walking through a park here right now, right? I could take that route right there, or I could take that route right there. They're both hopefully going to get to the other side of the park. One's going to be muddier, one's going to take longer, one I'm going to burn more calories on. If I'm in a rush, I may want to take that trail. If I want to take the sightseeing view, I might want to take this trail. That's the concept of sort of what-if branching, right? Now, what happens in most decision trees is they branch and they branch and they branch and they branch. And you end up at 80,000 different points depending on how many branches you create. What we built in our software is the concept that branches can reconverge. So yes, I can take this trail and it will eventually meet up with the other trail, and then I can carry on from that point. I've hit the same destination, but I've taken a different path. And yes, potentially I could take a different trail over this way and never actually get to where I'm kind of going, but that's the whole point of converging decision tree branching logic, right? So what we built in our software is a way to think about time, a way to think about these discrete little moments that represent actions in a timeline. So let's take this a step further. 1 + 1 = 2 today. But if I take that first one and I delay it by 6 months, and I take that second one and I delay it by 9 months, I add those together, it's no longer 2. It's some other number, because we've had to factor in not just the what, but the when. And that is where I think most modern tools fail. They don't really account for when. All right, so as I mentioned, I used to run this visual effects studio. We had 150 employees. We were bidding on anywhere between 10 and 12 projects at a time. Each of those projects could have multiple episodes, working on the latest season of Snowpiercer or Stranger Things or whatever it is. There's multiple bid packs. So it's very easy in a project-based industry, which is an industry that I love, to suddenly see that you have 50 or 60 chess pieces on the board. Some are worth $500 million, some are worth $50,000. Some are great relationship building projects. Other ones are great money-making projects. And others are those clients that you absolutely hate, but they always kind of come back to you. In a spreadsheet, there's no way of quantifying that soft stuff, right? It's just a number. It's just a cell, right? Now, instead, what we've done is we have taken all of these business logic moments and think Lego. We've created a library of Lego pieces, right? And those Lego pieces can connect together in all sorts of ways to create all sorts of financial and operational models. So think, for example, if you are running an ad campaign. What if I spend 10 grand a month on Facebook ads? What if I spend 20 grand a month on Facebook ads? What if my conversion rate is 5% or 10% or 20? What if my churn is 3% or 4%? What if my conversion from trial to paid to pro is 10% and 10%? Already there's easily 14 or 15 or 20 different combinations of those. And it's near impossible to run all of those in a spreadsheet as quickly as that. So let's go back to my days running a visual effects studio. So imagine having all of these chess pieces on the board, different dollar values, different start dates, but then the skills required to pull this work off are highly skilled. They are hard to come by. You're hiring people on a contract basis to offset your full-time employees. And you've got air dates, you've got deliveries. You have to deliver these things on time. So you can imagine you make all your money when you're busy. You lose all your money in between gigs, and delays of any kind, including staffing or delivery, can have a massive impact on your finances. Challenge right now is most project-based industries are winging it. Once you get to a certain scale, it is so complex that really all you can kind of do is think a week or two out and then have a gut feeling for the rest. And the reality is, I hate to say it, but your gut ain't that great, right? Imagine having a system instead where you could run all of these simulations at the same time. What if you're awarded everything in your pipeline? What if everything that is 80% or more comes to fruition? What if that massive project is delayed by 6 months? What if you're only awarded half the work? Or other sort of use cases. What if tariffs come along and suddenly now a bunch of your prices change and you have to adapt? What if you have to take out a loan to extend out your business timelines? Here's the trick. Everyone's trying to sprinkle AI on top of everything right now. That's pretty cool. You hear about large language models all the time, but you know what you never hear about? You never hear about large finance models. Why? Because it doesn't exist, and anyone tells you that it does is feeding you a line. Large language models are fantastic at using natural language to understand inference, to aggregate data. Of course, we all know it hallucinates. So would you now trust a large language model to run financial calculations for you years out in the future with a whole bunch of variabilities and dependencies, things that happen in 6 months, things that happen in 8 months, all that scenario planning? So that's not the case, right? Large language models are greater than large finance models. What if instead you could take all of that financial logic? Imagine all the pieces that are in your spreadsheet, all the concepts that are there, whether it's employee and staffing models or revenue forecasts, capacity models, loans, cash flow. And instead you could turn these into little building blocks. And back to that timeline concept I talked about before, what if you could take every single one of these building blocks and put it on a timeline? What if you could stretch out when it starts and when it ends, maybe shift the whole thing in time? Great, you now have a visual representation, like a Gantt chart, of some of your decision making. You've got a scenario. Right? Now the power of this model is, now imagine an algorithm that steps through every single one of those pieces day by day and calculates everything. On Monday, does a run through and says, how many employees do we have? How much are they getting paid? Has that big project started yet? What's our revenue projections? How many hours have we burned? How much server storage space have we taken up? And then it does Tuesday, and then it does Wednesday, and then it does Thursday, and then it does Friday. And what if it takes all of that information day by day by day and dumps it into like a ledger type system? Something that all the accountants here might be familiar with. You've got income and expenses and liabilities and assets, all those sort of sub-ledgers. What if you had ledgers for everything? Employees, those in Vancouver, those in London. What if it's customer cohorts? How many people are grown that month? How many are churned? How many have transferred in from another cohort? How many have transferred out? What if it's KPIs and metrics? What if it's estimated headcounts? So that becomes really powerful because now you have a language that's more intelligent than just that little tiny cell on a spreadsheet that says 1 or 50. What's the problem with that? That number means nothing to a large language model. That number is just a value, and you can associate what it means because hopefully there's a label next to it that says employees or deals or widgets. But there's no real metadata. That's not a smart number. And you're now asking a large language model to try to infer what all that means. Now imagine instead you have these events, and those events have everything like start dates and end dates, cadences, bespoke calculations, budgets versus actuals. So now what happens is when I see that my revenue is $50,000 in January, I know why. I know what made that value. I know what decisions created that value. And then if I want to try and use a large language model, it has access to all that metadata, all that context that surrounds that number. So that when I start asking questions of the data, I'm getting real information. So now where this all gets interesting is we still have our binary problem, right? In most systems, these numbers can only be one thing at a time. Yes, you can run a Monte Carlo simulation that rolls the numbers on everything. But what if you'd be more targeted? In a more targeted version of this, we can run what's called an override or a variant. So just as I'm back to walking through my trails here, I can say, what if I take that other trail, but it's just in this one version of the future? What if I change 60% to 70%, but just in this one variant? What if that big project is delayed by 3 months or 6 months or 9 months? All of those can live at the same time. We run through the decision tree, we do these what if branches, and now we're calculating multiple outcomes. We call them threads. And you can have 10, you can have 50, you can have 80. Now, can I tell you which one's correct? No, right? I don't know which one's correct. That's probably where your common sense comes in best. But I can start to help you understand trends in the data. Because the reality is, as smart as you are, you can only handle so much variability. You can only handle so much cause and effect. So instead, we can look at our trend analysis for revenue. I can see that in 80% of the scenarios, we are not going to have enough work for a particular department in Q1. And I can see in 50% of the scenarios that I'm going to have a cash flow problem in Q3. This gives you the ability to start to scenario plan, to start think about decisions well in advance, to be aware of where your bottlenecks potentially are, and also where you're perfectly fine. Right? One of the most beautiful things about scenario planning is the ability to walk out of that meeting and just say, everything's going to be all right. How many times have you been in a staffing meeting or a production meeting or a finance meeting, and someone says, that's a great question, let me get back to you? Or you're asked if you are sure, and the answer is you're not. You have no idea, because there's so much complexity. So let's kind of get back to the large language model versus the large finance model. So this is where I like the term large finance model. We're familiar with large language models, right? And if you're not familiar with how they work, it's really just this algorithm that runs through, tries to pick what the next word is. It's probabilistic. It is not going to give you the same answer every single time. 1 + 1 always has to equal 2. It can't be 1.1. It can't be 2.1. It can't be 1.9. And it can't be Bruce. So the beauty of a system that is deterministic, like ours, is those calculations are always going to be correct. You do them outside of the traditional large language model, and then you serve it up to whatever your LLM of choice is to try to make sure that it can use that in its conversations. So if you then want to ask which of these scenarios is best and why, you now have both the numbers and you have the information that created those numbers. So here's why I like project-based industries. They are complex. You have these big chess pieces, whether it's construction, whether it's agency work, whether it's media and entertainment. There are so many pieces that go into the ability to deliver that on time, and they all have a cause and effect on each other. Each of these businesses needs to succeed. Each of these projects need to succeed. And we've all been at the resource table where everyone was fighting over the scraps for who can help which project that's in trouble. And like a little league soccer team chasing after the ball, we run from one project to the next, trying to solve the problems of the day. We need a system where you can map out all those things in advance, where you can see all the possible twists and turns, and then start to make data-driven decisions, or at least start to cull down your variety of options so you've got something you can focus on. Here's why I think spreadsheets are going to hit their limitations. Understandably, the finance world and the operation world is used to the tools that they have, and they're excited about artificial intelligence, right? But really, what is a spreadsheet? A spreadsheet is a way of a financial modeler, an executive, a team, taking what's in their head and formalizing it in a structured sort of way, which is great. But that's their brain, and it's only their brain. If you've ever inherited a spreadsheet from someone else, the chance of you being able to pick that spreadsheet up and understand the logic inside of it is close to zero. Yeah. The more complex it gets, the even closer it is to zero. So imagine now, instead of system, I'm going to go back to my Lego, where each of these pieces fits together logically. They are structured, they are modular. You can have what I call like an income event or an expense event. You can have an employee event. In an e-commerce model, you can have a cost of goods sold, you can have a product, you can have its margins. It's all straightforward business logic. Almost no different in your spreadsheet where you are going from one tab to the next, but each of these represents discrete business logic. And depending on the order you connect them together, they're structured, they're not going to change, the order can change, the dates can change, but the logic is always going to be consistent.